Hi everyone, today in Integrated Math 1 we're going to go over Chapter 14, Lesson 1. Here are the objectives. Make sure you write them down in your notes. Alright, let's go over our new postulate. Angle-angle similarity, also known as AA similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So when I'm talking about that the triangles are similar, I'm not saying that they're congruent, but notice it has like the same shape, they look the same, except one is either stretched out or made smaller. So for triangle ABC and to triangle FGH, it went from big to small. But notice the two angles are both congruent. So angle A is congruent with angle F, and angle B is congruent with angle G. Because of that, I now know that triangle ABC is similar, that's a symbol for similar, to triangle FGH. Notice the lettering, very specific, just like when we're talking about congruent triangles. Alright, so let's go over our triangle similarities. So side-side-side similarity, or SSS similarity. Notice this sounds like when we were talking about congruent triangles, except now we're talking about triangle similarity. So it's like it, but it's not the same as. So if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So what they're saying is, in our case, JK is proportional to MP, which is equal to the proportion of LK divided by PQ, which is also equal to the proportion of LJ over MQ. So let's say that when you divide each of these numbers, that we get 3 is equal to 3 is equal to 3. If these are all the same, then we know that they are similar, that they were all stretched or shrunk the same amount. So in our case right here, we know that JKL is similar to triangle MPQ. Then we have side angle side similarity, SAS similarity. We have a side, an angle, and a side. Side, angle, side. So our side lengths are S, which is proportional to YX. And we also have our other side, ST, which is proportional to YZ. They must be proportional, which means they must, just like up here, when we checked them off, that 3 is equal to 3, or whatever it may be. And the angle one, that one's easy. We're saying this angle is congruent to this angle. And if this is true, then we know that triangle RST is similar to triangle XYZ. Alright, so let's go over the properties of similarity. These should sound familiar, except now we're adding the similarity aspect to it. So the reflexive property of similarity, if triangle ABC is similar to triangle ABC. It's the same order, nothing's changed. Then we have the symmetric property of similarity. So if triangle ABC is similar to triangle DEF, then triangle DEF is similar to triangle ABC. It just flip-flops. Then we have the transitive property of similarity. If triangle ABC is similar to triangle DEF, and triangle DEF is similar to triangle XYZ, then we know that triangle ABC is similar to XYZ. So notice like this portion went away, leaving us with these two. Alright, so this is just to make sure you see everything the different kinds of similarities. We have AA similarity postulate, side-side-side similarity postulate, and side-angle-side similarity theorem. And there we go.